clear? Kindly confirm. Thank you. Good evening to all of you and welcome to Byjus Exam Prep IAS. Welcome to today's session of climatology, where we shall be proceeding ahead with the portion of humidity, and furthermore we shall be trying to understand the various different forms of precipitation and how that precipitation is basically influenced or is impacted. So what is it that we looked at yesterday? Yesterday, basically, we tried to understand the air circulation, where we developed on the concepts of air pressure and the movement of the wind. So we looked at the various different factors which influence the wind motion. We took a look and a detailed understanding of the factor of Coriolis force, what this Coriolis force is, why is it that this Coriolis force is in action, where we saw that that is a kind of a force which is acting purely because of the rotation of the planet on its axis. And as the planet being spherical rotates on its axis, different regions across the planet, they end up representing different speeds of rotation. And hence, as the object or as let's say a wind movement happens between these different areas of the planet, they will experience a kind of a deviation. So we saw that the amount of Coriolis force or the Coriolis effect is maximum at the region of the poles and is almost zero at the region of equator. So after that, we looked at the frictional force. The concept of onshore and offshore winds is something that we understood. And then after that, we understood the prospects of the air circulation. That air circulation happens why? Because different areas of the planet receive differential amount of heat. So for the heat distribution, you do need a kind of an air circulation to happen. So we looked at the unicellular model of circulation provided by Hadley, and then we looked at the tricellular model of circulation, which where we saw the presence of three atmospheric cells of circulation created in each of the hemisphere, and hence the name tricellular model of circulation. Now, as per the tricellular model of circulation, we observed the presence or the creation of the doldrums or the different pressure belts, that is the ITCZ, the subtropical high pressure belt, the subpolar low pressure belt, as well as the polar highs. And we also observed that all these different pressure belts, they end up shifting with the change of seasons. When you have the summer in the northern hemisphere, all these pressure belts significantly shift to the north. And when you have the change in season, in the sense that you have summer in the southern hemisphere, all the pressure belts led by the ITCZ, they end up shifting to the south. Because you have in each of these circulations, you have the creation, or in each of the hemispheres, you have three different cells which are created. That is the Hadley cell, the polar cell, and in between them, you have the presence of a Ferrel cell. Now, while Hadley cell and polar cell, they are dependent upon the thermal high pressure and low pressure created at the region of the poles and equator. In the case of the Ferrel cell, that is led by the presence of the dynamic pressure zones which are created at the subtropical highs and the subpolar lows. Now, after that, we also took a look at the various different permanent wind systems. Why are they referred to as permanent wind systems? Because these are the wind systems which are in existence throughout the year and are also prevalent across the entirety of the planet. Now, there we observed basically that you have the presence of the trade winds, the westerlies, as well as the polar easterlies. The directionality of the wind is oftentimes determined, or the naming of the wind is oftentimes determined by the region where they originate or the direction from which they originate. Then, after that, we took a look at the local wind systems, and before that, we also took a look at the pressure zones created, where we observed the formation of Icelandic low, Azores high, or Bermuda high, and so on. Now, after that, we did analyze the presence of the various different local winds, where we actually classified the local wind system into the daily local winds or the local wind phenomena which we experience on a daily basis. For example, land and sea breeze, as well as the mountain and the valley breeze. And also, we took a look at the wind phenomena which is observed on a seasonal basis, such as you have Lu, Fohn, Sirocco, Mistral, Chinook, etc. Now, after this, we moved on into the portion of humidity and precipitation, where we understood what do we mean by humidity. And there we observed that the total carrying capacity of an air, basically, what do we mean by carrying capacity? The amount of water vapor that any air parcel can accommodate within itself, that is what we defined as the carrying capacity. So carrying capacity of air varies from one region to another and varies with respect to temperature, where we saw that when you heat up the air parcel, then the particles tend to escape, and within that air parcel, you can always end up accommodating greater amount of water vapor. So with heating, the carrying capacity of the air parcel increases, whereas when we talk about cooling of an air parcel, that brings the particles and the molecules much closer to each other and reduces the carrying capacity. Now, yesterday I had also told you to take a look at the portion of latent heat of condensation. How many of us have taken a look at latent heat of condensation? Good? Perfect. So I hope today we won't have to spend energy in understanding the aspect of latent heat of condensation. So that latent heat of condensation is also going to be important for us when we try to understand complicated concepts such as the formation of a tropical cyclone. That is where that latent heat will come to significant and immense amount of help. Now, today we are going to take a look into the other factors associated with humidity, the basic classification of humidity relevant only for your identification purposes. We'll take a look at why and when condensation happens. And then after that, we shall also be taking a look at the aspect when we talk about, let's say, the cloud formation, the occurrence of thunder, lightning. Why does that happen? The classification of various different clouds, the types of rainfall that happens. What do we understand by hailstorm? What do we understand by a cloudburst event? When does it happen? Why does it happen? And what do we understand by fog, the classification of fog? And after that, we will be moving on into the portion of air masses and cyclones, where we shall be studying about the different types of fronts, the kinds of temperature and the climatic conditions experienced in different frontal formation, what is frontolysis, what is frontogenesis, the development of a temperate cyclone, as well as the development of a tropical cyclone. Okay, so here it is a heat released when vapor condenses into water droplets. Yes, Shubha, that is correct. So here, by which instrument scientists identify rainfall? If you are talking about the amount of rainfall that is caused, so with the help of rain gauge that we looked at earlier in the sixth module, we had taken a look at the rain gauge. Okay. Yes, Mayank, that is correct. So most of you, I gather, you have almost all of you have studied about the portion of latent heat of condensation. That is very, very important in order to understand the basic concept about the process of a formation of tropical cyclone itself, because tropical cyclone is a complex phenomena and it happens because of a combination of many different factors taken together. So that is where latent heat of condensation plays a very substantial role. Okay. So now we carry further with the aspect of temperature, humidity, and temperature. So here, when we talk about it, so basically, water carrying capacity of an air parcel varies with the temperature of air. So a warmer air parcel can hold more amount of vapor as compared to a colder air parcel. That means when we talk about, let's say, heating of air, heating of air, it increases the carrying capacity of air. Means the air can accommodate more water vapor. Accommodate greater amount of vapor. And cooling of air will reduce the carrying capacity. Okay. That is something that we looked into. Now, When we talk about this humidity or the amount of moisture present in air, so how do we end up measuring that? So there are various different methodologies. So basically, the classification in terms of the various different measurements of humidity, you will find that you have the presence of absolute humidity, a term that we refer to as absolute humidity, specific humidity, and also what is referred to as relative humidity. All of these end up representing the total amount of vapor which is trapped in an air parcel. But here, all of them, they carry out their measurements in different ways. So, for example, when we talk about the relative humidity, or rather when we start with the portion of absolute humidity. So, what do we mean by absolute humidity? So, this basically measures the total weight of water vapor present per volume of air. Volume here can be, let's suppose, 1 meter cube. Okay. So, here, let's suppose we consider any volume of air parcel. And let's say its volume is 1 meter cube. Now that is the volume of air. Okay. Now, here, when we say the volume is 1 meter cube, in that volume of water or in that volume of air rather, let's suppose you have the presence of water vapor particles as well. Now here, let's say that the total weight of all these water vapor molecules, let's suppose it comes out to be 5 grams. Weight of vapor, if it comes out to be 5 grams. So thereby, what do we mean by the case of absolute humidity? So if you have to represent absolute humidity, it basically comes out to be the weight of water vapor per volume. So what will be the absolute humidity in this case? It will be the weight of vapor divided by volume. That is the case of absolute humidity. So this will come out to be 5 gram per meter cube. That is referred to as the absolute humidity. Okay. In general, you will observe that it decreases, the absolute humidity decreases from the region of the equator to the poles. Now think about it, that why does it happen? Why is it that the absolute humidity in general will reduce from the region of equator as you move to the region of the poles? Why is it that the amount of absolute humidity is lesser? Very good. Because of decrease in temperature. When there is a decrease in temperature, in general, the moisture carrying capacity reduces. So the amount of moisture or vapor present will also be reducing. So that is why there is a decrease in absolute humidity. That is because there is a decrease in temperature. Temperature towards poles. And what it does, reduces the carrying capacity. Okay. It will end up significantly reducing the carrying capacity, and that in a way will reduce obviously the amount of moisture present. Reduces the moisture present. Okay. So that is where you will observe that overall the portion or what you measure as absolute humidity will reduce from the region of equator to the poles. Now, this is a variation that you observe in the measurement of absolute humidity, but that is not something that you will observe in the case of specific humidity. Specific humidity, it is also a measurement of humidity or the moisture present itself, but it is slightly different in the sense that when we say specific humidity, it ends up measuring the total weight of the vapor per kg of air. Earlier, we had per meter cube of air where we were considering the volume of air. Now we are considering the mass of air. So the total weight of vapor per kg of air. So for example, let's suppose that in order to form 1 kg, now here when we say kg of air, so that mass of air will be constituted by the dust particles, will be constituted by the various different gaseous molecules, etc. So let's say here you have 1 kg of air. So in this, if you have the presence of vapor, okay. So let's suppose the weight of vapor, let's say is 10 grams. Right. So here, what will be the specific humidity? It will be 10 grams divided by 1 kg. Now, if I ask you, will this specific humidity have a unit or will it be unitless? What do you think? Good, Manikandan. Will this specific humidity indicate a unit or will it be unitless? Very good. It will be unitless. Why? Because both numerator and denominator are represented in the form of kg and grams. So that is why it is always going to be a unitless quantity. Okay, so that is where you will observe it is a unitless quantity. Okay, so it represents the actual quantity of moisture present in air and is seldom affected, that is rarely, seldom means rarely affected by change in volume or temperature. Why? Earlier, in the case of absolute humidity, we have seen that as you move from the equator to the poles, there is a reduction in temperature, so there will be a reduction in absolute humidity. But here you won't observe that change in specific humidity measurement because let's suppose the temperature increases or an air parcel is heated up. So when the air parcel is heated up, there will be various different particles which will escape the system. But nonetheless, in order to capture 1 kg of air mass or 1 kg of gaseous molecules, dust particles, etc., you will have to consider a larger existence itself. So that is where the amount of vapor present is going to be consistent. Why? So here it is seldom affected by change in temperature and volume because we consider the measurement of mass of air. So even if let's suppose you heat it up, so even after heating, if the volume increases, doesn't matter because eventually 1 kg will be represented by the same number of air particles, the same number of dust particles. So if you consider that volume or this volume, 1 kg will be 1 kg. It's the same number of particles. So that is why the specific humidity is largely consistent. Then we have what is referred to as relative humidity. Now, what do we understand by relative humidity? So here the term of interest is relative. Now, relative is always something that you compare to, in comparison to. So when we talk about relative humidity, that means you are comparing it to something, isn't it? So here, the total amount of moisture which is present in the air parcel at any point of time in comparison to what is the total carrying capacity. So at any point of time, at any given temperature, what is the total amount of moisture present in the air as compared to what it can carry, right? So for example, so it is the ratio of amount of water vapor present in air to what it can hold. So when we consider an air parcel, let's suppose any kind of volume, anything. So let's suppose this is at 25 degrees Celsius. Okay. So here at 25 degrees Celsius, if the carrying capacity, let's suppose is 10 grams and the vapor present is 5 grams. So what will be the relative humidity? The relative humidity will be the ratio 5 by 10 into 100. Always relative humidity is something expressed in percentage. So that comes out to be how much? 50%. So that is where whenever you open up the newspaper or whenever you read the or listen to the news headlines, the weather report, etc., you will always hear the figure that the humidity level in, let's suppose, Delhi is 30% or 45%. Humidity level in Kolkata, let's suppose, is 80%. That means that at that particular temperature, the air is holding 80% of the moisture in comparison to what it can overall carry. That is the relative humidity. So in comparison to what can be held. Okay. So that is your aspect of relative humidity. Now, will this be impacted by temperature? Yes or no? What do you think? Will this be impacted by temperature? Very good. Absolutely yes. This will be significantly impacted by temperature. So for example, let's suppose this same air parcel, let's suppose I heat it up and I provide heating. Okay. And I heat it up to an extent where the temperature goes to 35 degrees Celsius. Now, the carrying capacity, let's suppose from 10 grams, it has increased to 15 grams. There has been no net addition in the vapor present. So the vapor present is still 5 grams. So what will be the relative humidity in this case? Good. All the intelligent people who are going to appear for CSAT, will it be 300%? You need to get through CSAT, guys, in order to qualify for the mains examination. Yes. So it will be 5 by 15 into 100. That comes out to be 33.3%. So if the total amount of vapor is consistent with the rise of temperature, you experience a reduction in relative humidity. On the other hand, let's suppose that you provide some amount of cooling. Now, when you provide cooling, let's suppose you cool it down to 10 degrees Celsius And at 10 degrees Celsius, let's suppose the carrying capacity comes out to be 5 grams. Vapor present is the consistent one, that is 5 grams. So I'm holding an easier calculation for you guys. So relative humidity will be how much? 100%. Very good. So that comes out to be 100%. So can we have a conclusion that with the heating of the air, if the total amount of vapor present is consistent, the heating of the air will always reduce the relative humidity, and the cooling of the air always ends up increasing the relative humidity. So if the relative humidity is 100%, that indicates that the amount of moisture is as much as the air can hold in total. Air cannot hold any more amount of water vapor present in it. So that is where relative humidity if the vapor present is constant, total RH increases with cooling and decreases with heating. Okay, that is the aspect of relative humidity. This gives us an idea about when the rainfall can happen, when is it that we can expect basically the kind of, let's suppose, uh, precipitation of any sorts, dew formation, etc. So if the relative humidity, let's say, exceeds beyond 100%, that means what? There is surplus amount of moisture. Relative humidity cannot go beyond 100%, because water cannot carry any, or the air cannot carry any amount of moisture more than its carrying capacity. So whatever surplus will be there will start to condense. Okay, now that brings us to the portion of saturation of air. What do we mean by saturation? So you would have studied it in your class 6th, 7th level of science as well. That when we talk about saturation, generally you would have heard about or read about in those young days about the water as a solution, where you add salt or sugar into water, you dissolve them, it keeps on getting dissolved till the point that the water gets saturated. Water cannot accommodate any more amount of dissolved salt or sugar. And when you start putting in more salt or sugar, that is when it starts forming the on the base or starts getting deposited. That is because the water is completely saturated. Similarly, when the air is holding as much amount of moisture as it can carry, that is when we say that the air is saturated. So the air containing moisture to its full capacity at any given temperature is said to be saturated. Okay, so whenever the air is saturated, what will be the relative humidity when the air is saturated? Very good. So relative humidity comes out to be 100%. Okay, so whenever the air gets saturated, relative humidity comes out to be 100%. So that is the matter and the aspect of relative humidity overall. Now, so let's suppose when you have an air parcel with the relative humidity, let's say, of 85%. Okay. Now, here, when I cool it down, let's suppose the temperature is 25 degrees Celsius. Let's suppose I cool it down to 15 degrees Celsius. The relative humidity here becomes 100%, let's suppose. Right? So that means the air has reached saturation. So any unsaturated air, when you cool it down, it can get saturated if you cool it down to the point where the relative humidity becomes 100%. So this is your unsaturated air. Unsaturated means there is a greater scope that more 15% more moisture can be accommodated here. Here there is no scope for further accommodation of water vapor. So unsaturated air, and this is your saturated air. Okay. Now suppose I heat it up again. It is not that you and I can put fire into the air and heat up the air. It is generally heated and cooled down by the activities of the atmospheric condition itself. That is what the heating and cooling here refers to. So suppose when the air gets heated up again, suppose, and it gets heated to, let's assume, 20 degree, or rather 20 degrees Celsius here. Relative humidity comes out to be 90%. This will again become unsaturated. So that means that a saturated air, when it gets heated up, that means its moisture carrying capacity will increase. That means relative humidity will reduce. That means it becomes unsaturated. So saturated air, when heated, becomes unsaturated. Now, what if I were to cool this down further? Let's suppose here the carrying capacity is, let's suppose the carrying capacity comes out to be 10 grams. Let's suppose the moisture present is again 10 grams. So here, that is why the relative humidity is 100%. That is why the saturated air. Now let's suppose I cool it down further. Upon further cooling, so in this case, if I cool it down further, I bring the temperature to 10 degrees Celsius. Now in that case, the carrying capacity comes out to be 10 grams, or rather carrying capacity will also reduce, in fact. So let's say the carrying capacity is 8 grams, but we have seen that the moisture which was present in the air was 10 grams, but the air can accommodate only 8 grams now. Why? Because the carrying capacity has reduced. So what will happen to the extra 2 grams which was present in the earlier present air? What will happen to that extra 2 grams? Those extra 2 grams, they will accumulate as condensates. They will start condensing into liquid water droplets. So here, with the reduction in carrying capacity, the extra vapor here refers to more than the carrying capacity. So here, what is the extra vapor here in this case? So you have 2 grams as extra vapor. So that will condense into liquid, or sometimes even ice. If, let's say, in order to attain the temperature, because here we are considering 10 degrees Celsius, so it will get converted into liquid. But let's suppose that in order to reach saturation, it has already taken 0 degrees Celsius. And then further cooling to minus 5 degrees Celsius, that is when the air has become oversaturated. That is when you have the extra molecules. So then, rather than getting converted into liquid, vapor will directly get converted into ice. So here, when we talk about the aspect of saturated air being cooled down, so cooling of saturated air leads to condensation. So that means, as of here, air can only accommodate 8 grams. Vapor present can only be 8 grams. So the extra 2 grams, that will be saturated, that will be condensed. So always, whenever you need to have condensation, or whenever you have condensation that you experience, it is basically when the air gets saturated and cools down beyond the point of saturation. So we can say condensation will happen only when the air parcel gets cooled down beyond the point of saturation. So condensation happens only when the air cools down beyond the point of saturation. Okay. That is what you will experience in this case. So always, that is the key to saturation. So whenever you, or the key to condensation. So condensation will never happen when the air is unsaturated. Condensation, wherever it will happen, will only happen when the air gets cooled down to the point of saturation and then further cool down. That is when it will get, or you will experience condensates to happen. So condensation, basically the small drops of water which form when the water vapor or steam touches a cold surface, such as a window, such as any surface, glass surface, etc. So condensation is something that we experience on a day-to-day basis as well. Particularly in these months, you would have observed that when you take out, let's say, a bottle from the fridge, refrigerator, any bottle from the refrigerator, or any utensil from the refrigerator, you would have observed that when you keep it outside, small droplets of liquid or small droplets of water, they develop outside. You would have observed this, that when you take out a bottle from the refrigerator, right, in these months, or any of the utensils, not only a bottle, and you keep it on the table, would you experience? You will experience that on this bottle, small droplets of water will accumulate on the outside, on the surface. Small droplets will develop on all sides, just like you see here. Now, where do these droplets of water come from? Have you ever tried to understand that, or have you ever tried to question that? That if I'm bringing out a utensil and keeping it on the table, you have droplets of water accumulating on them. Where does that droplet come from? What do you think? It is the water vapor of air. So, how does that condensation happen? So that is again because of the cooling of air. And it happens because of the simple process of conduction. So let's suppose this particular bottle is, when you have kept it in refrigerator, let's suppose it is 1 degree Celsius, the temperature of the bottle. Now, the air which is outside in the environment, and you would also have experienced this, that let's suppose, or if you have not, then try it today. keep a very cold object outside of refrigerator on the table. As you put your hands closer to the bottle, you will feel the air getting colder. As you move it away, there is no impact. But as you put your palms or hands very close to the bottle, the air gets colder. So let's suppose we consider this particular air parcel here. Now let's suppose earlier the temperature of this parcel would be, let's suppose, 20-25 degrees Celsius. The temperature, let's assume, is 25 degrees Celsius. Now, here, when the earlier the temperature was 25 degrees Celsius, there was unsaturated air. And at this temperature, let's assume it was unsaturated air. Okay. Now, as you are keeping it with the bottle, now there in that condition, as you're keeping the bottle on the table, this air will get in contact with the bottle. Bottle surface is 1 degree Celsius. So what will happen? Because of being in contact, these small drops are from air, not from water under the bottle. Is that the kind of confusion that you have? So in that case, do one thing. Try to put a utensil, fill it with vegetables into the refrigerator. Take out that utensil, keep it on the table. There you won't have water coming from the vegetable into the outside, but still you will find droplets developing. I'm sure you would have seen till now multiple times in your life, hundreds and thousands of times, that you have a soda bottle or a cold drink bottle. Now, when you keep the cold drink bottle on the table from the refrigerator, it develops those droplets. So, do you think that those droplets are basically your Coca-Cola and Pepsi leaking out of the bottle or the glass bottle? Can that happen? That from inside the bottle, the cold drink is leaking out and then forming the droplets? If that would have been the case, then all the condensates would have different taste in itself. You could have accumulated them as well. So that how can that happen? That from inside the water will simply peep out and seep out of the glass bottle. That is simply impossible to happen, isn't it? So here in that case, what you observe, that because of, and in case you have been just informed of this particular fact in your life, then congratulations for the eureka moment in your life for the first time. But I would want you to take a deeper look into this and try it out on your own. Do this experiment on your own, and then think about it, that how many such questions you have had misconceptions about in your entirety of life. Because the condensation is not dependent on whether you keep water inside, ketchup inside, or whether you keep, let's suppose, any particular item in the fridge. You keep it out, you bring it out, it develops small droplets. So I want you to try this out for everyone for whom it is a kind of a new piece of information. So this is where air surrounding the bottle, what will happen to this air gets cool down. Okay, it gets cooled down. Why? Because it is in contact with the air. One degree Celsius bottle, and then reaches saturation. How can you say that the bottle is sweating? Reaches saturation, cools beyond saturation, and then what do you have? Condensation, which happens. I'm surprised to find out that how many of us have not realized this till now in our lives. We have grown up with this reality for a significant proportion of life, for our life. Why only in refrigerator? Because it is in refrigerator that you have such low temperature. Can you have such low temperature outside? It doesn't happen. And if you are surprised by this, let me throw another surprise at your doorstep again. So if I don't know if you have observed it or not, but then during rainy season, you will observe that when you keep a bottle outside from the refrigerator, and if that bottle is cold enough, there will be much greater accumulation of water droplets on the table or whichever surface you are keeping. And then in the summer season, there will be lesser accumulation, or in the winter season, comparatively lesser accumulation. Why? Because in the rainy season already you have significant amount of moisture which is present in the air. Humidity is high during the rainy season, so that is why it reaches the point of saturation very quickly and cools down beyond that. Okay, I hope you have observed this. If not, please try to observe it from now on. Yes, in the air conditioning room, it happens on the window glasses and the window frames as well. When you're traveling through your vehicle, in your cars also, when the temperature is significantly low inside, you will develop these droplets happening on the glass windows outside. So that happens. Okay. So that is basically what is condensation. This same simple process is at play. This simple process of condensation is at play when you talk about, let's say, the formation of clouds, development of dewdrops, development of frost, etc. Water of earthen pot also gets cooler with the same. No. In the case of the earthen pot, you have a different scenario altogether. There, the water gets cooler because the earthen pot has actually got pores within them. And through those pores, you have the water which evaporates. It is the evaporation which provides that rate of cooling, and that is why your water is cooler in the earthen pots. Nagul, why there is formation of droplets in bike seats during winter? The same process, because the surface becomes much colder. Eyeglasses also, yes. Okay. While cooking any food item, upper part of plate also gets, it is also condensation. Yes. Didn't understand why the air in contact with the bottle gets saturated, because here earlier the temperature, if you consider the temperature in your room, the temperature of your room might be 25 degrees Celsius. But in this immediate vicinity, when that bottle is kept, so in that immediate vicinity, the air is in contact with the surface which is at 1 degree Celsius. So won't it attain a much lower temperature? So in that process, it will attain saturation and it will be cooling down much. So let's suppose the saturation temperature of air in your room is, let's suppose, 10 degrees Celsius, and the air around the bottle attains a temperature of 5 degrees Celsius. So it will get oversaturated, condensation will happen. Okay. Now, after that, we come across a process or the form of condensation that we refer to as dew. So what is dew? Dew is something that you observe on, generally in the coastal areas, you observe it throughout the year. Generally, otherwise, in the significant northern part of the country or across the country also, during the cold winter months at night or in evening, you will find that small droplets, they end up developing on anything, on your surface, on the surface, as you said, of the bike seats, on the surface of, let's say, your cars, on the ground surface. Everything develops small droplets of water. That is what is referred to as dew. This is also a form of condensation. So, this also happens when the air in contact gets cooled down beyond the point of saturation. Okay, so tiny droplets of water that form on cool surfaces. So if you see the grasses, on the blades of the grasses, you will observe the development of tiny droplets, isn't it? So tiny droplets of water that form on cool surfaces at night when atmospheric vapor condenses. Now, when will it condense? When the saturation temperature is attained. when the point of saturation is attained and it is cooled down beyond that. So let's suppose you have the air parcel here. Let's suppose. Now for this, the saturation temperature is the point at which the air will attain saturation. So let's suppose the saturation temperature is 5 degrees Celsius or 15 degrees Celsius. Okay. Now, if you have the ground surface cools down, temperature is 5 degrees Celsius. So as this air parcel gets in contact with the surface, its temperature will also drop to 5 degrees Celsius. So then what will happen? It has been cooled down beyond that saturation temperature, isn't it? So that is when it will undergo condensation. Now, remember we had talked about it in the previous week itself, that for condensation to happen anywhere, you require a surface. Without a surface, condensation can never happen. So if here the condensation takes place, it will get deposited on the surface, on the grass particles, or let's say any surface, any metallic surface that you have, it will start condensing on them, isn't it? So that is what is observed as dew. Okay, so this is observed whenever the air cools down beyond the point of saturation and the condensates, they settle or deposit themselves on any particular surface. Now, the temperature at which this saturation takes place, that is what is also referred to as the dew point or the dew point temperature. Okay, so this is also, the dew point is the temperature the air needs to be cooled in order to achieve a relative humidity of 100% or in order for the air to be saturated. So that is your dew point. Dew point. So dew also is formed by what basic process? By the process of condensation only dew will be created. So this is, dew point is temperature at which air becomes saturated. Okay. Now, there are certain conditions when the air is very dry, Suppose the air is very dry. That means the humidity level is less. So suppose the air is having a relative humidity of 25%. Okay. Temperature is 20 degrees Celsius. Now suppose this cools down. I have reduced the temperature to, let's say, 15 degrees Celsius. Relative humidity, will it increase or decrease in this case? When I have taken the temperature for 20 from 20 to 15, will the relative humidity increase or decrease? Very good. So relative humidity will increase. So in this case, the relative humidity becomes how much? Let's assume it becomes 50%. Okay. Then further I cool it down. I take the temperature to 5 degrees Celsius. Relative humidity will again increase. So let's say it becomes 90%. Till this point of time, any dew formation will take place? Will there be a dew formation in this case? Very good. Absolutely no. Right? Because dew point temperature is when when you have the relative humidity which is 100%. That is when the air is saturated. Okay. So now further I cool it down, or the air further gets cooled down. Let's suppose it is a winter night and we are talking about, let's assume, a region of Ladakh, for example. So temperature reduces to 0 degrees Celsius. Then the relative humidity in this case reaches 100%. Right? So in this case, can we say that the dew point temperature is 0 degrees Celsius? Right? So here, dew point is 0 degrees Celsius. Okay. But here also saturation will not happen, because or here also condensation rather will not happen, saturation will happen. So the air is saturated at this point of time, isn't it? That is where when we have the dew point. So here air is saturated. Okay. So in this case, let's say I cool it down further and the temperature is minus 1 degree Celsius or minus 2 degrees Celsius. Now, in that case, what will happen? Will there be a dew formation or not? Right? But will that be liquid water droplets, or rather will there be condensation? Yes. But the condensation here, will it be liquid water droplets or ice particles? Ice. Perfect. Because we are at a negative temperature. So here condensation will be in the form of ice particles. Condensation is in the form of ice. That is why in certain parts of the northern part of the country, you would observe, particularly in the region of northern Punjab, Himachal, heights of Uttarakhand, as well as Jammu Kashmir, Ladakh, you would generally have a kind of a behavior where during the early mornings of the or during the late winter nights, you would observe that the surfaces, they develop thin pieces or thin sheets of ice on them. Right? You will develop that the surface has got the thin film of ice developing on them. That is what is referred to as frost. Okay, so that is what we understand as frost. So when you have the dew point temperature lower than 0 degrees Celsius or at 0 degrees Celsius, condense on the surface, condensation will happen in the form of ice particles. And these ice particles which settle on the surface, that is what we refer to as frost. Okay. So these ice particles overall, when developed on a surface, that is what we refer to as frost. Okay. That is what is referred to as frost. Is that understood now? Good. Climatology feels very tough. Gulam, have you revised the portion of 6th and 7th module, the sessions that you had missed out? Have you revised that? If you have not revised that, then this is something which will simply fly over your head. That is why I told you to revise that. Okay. So if you get the basic concepts, all of this, see, please understand, this is a subject which is very different, guys, from the portion of your polity, from the portion of history. Because in those subjects you miss out 4 classes, you sit in the 5th class, still you will be able to understand the non-cooperation movement. It is not as if that if you have not studied 1857 revolt, you will have no clue what happened in non-cooperation movement. It is not as if you have not sat for the class of preamble, you will not understand the money bill and the finance bill. You will understand that. This is a different subject, my dear friend, and that is what I told you in the session 1 itself. If you have no clue what has been taught earlier, there will always be a build-up of concepts, right? So there are two choices in front of you. If you miss out on one portion, if you don't revise it, then you will leave the entirety of the subject. Or you ensure that you maintain a regular revision of the topic and it will automatically come to you. Okay. And 0 degree dew will be formed. No, I said that dew point is zero. What is dew point? Dew point is when you have a relative humidity of 100% which is attained. That is what is dew point. How clouds have patience, my dear friend. Understand till this point of time. Then we will talk about cloud formation. Next topic is cloud formation itself. In case of unsaturated air, dew will not form. No. Saturation of air is when the air carries as much amount of water vapor as is the carrying capacity of it. That is when we say it is saturated. I hope we understand the English meaning of saturation. Is that understood? Or is there a doubt in the English meaning of saturation? English meaning of saturation is understood, right? So when you have anything which is saturated means what? It means there is no further accommodation of any substance in that, right? So that is basically what we refer to as the aspect of saturated air, means the relative humidity is 100%. In the previous example, you had said that when saturated air is further cooled, the carrying capacity will decrease and the condensation takes place. But in dew point example, you are saying it will increase. When am I saying that the carrying capacity will increase? I'm not saying the carrying capacity will increase. If the carrying capacity, see, relative humidity is increasing, my dear friends. It is not the carrying capacity which is increasing. Relative humidity is increasing means the carrying capacity is reducing. Okay, is that understood? How condensation happens in AC rooms in the rainy season? Because the temperature drops and the air reaches saturation. What is it in Hindi? I don't know the Hindi meaning of this. I apologize for that. I don't know the Hindi translation of this, and I'm sorry for that. Uh, can dew point temperature happen in temperatures above 20 degrees? Absolutely, yes. Why not? At dew point, the condensation will not there. No, when cooling happens beyond dew point, even zero point 0.1 degree Celsius of cooling, when it happens beyond the dew point temperature, condensation will happen. When we refer pack or parcel, is there any dimension of it? Absolutely not. What causes vapor to water droplets? Cooling. Vapor is a gaseous part of water, liquid water, and then you have solid ice. So you have solid, liquid, gas. You would have studied that. I'm sure I don't need to be spending time in helping you understand what is solid, what is liquid, and what is gas. I expect that much level of information from you, because if that information is not there, it is always better to revise from the class fifth portion or fourth portion, class fourth level again. That what do we understand by solid, what do we understand by liquid, what do we understand by gas. So vapor is basically the gaseous form of water. Water in itself is liquid, and then when you solidify or you cool it down, you get ice. Okay, important for prelims? Absolutely yes. Mitisha, you can take a look at the recordings of the sessions, or you can join a new batch altogether. Can low temperatures have dry air? Absolutely yes. If the amount of moisture present in the air is very less, why not? Hail for see, again I am telling you, have we talked about hail right now? Have we talked about the cloud formation as of now? Kindly hold your doubts of hail, etc. I know many of you are very knowledgeable. I know many of you have read a lot of things. So please hold your horses. when we come there, we will automatically talk about this. Okay. When I was in the portion of geomorphology, many of you were asking me questions about the wind movement. When I was in wind movement, then you had the same people asking questions about geomorphology. So please pay attention to the portion that we have covered as of now. Okay. Varaprasad, you can try to have a concept of the from the recordings, but then always I suggest that participate in the live discussions. And is dew point always zero? No, absolutely not. Okay, let me give you another example then. Let's have another example. How saturated air is formed. Did you join the session late, my dear friend? We have discussed about the entire process of saturation here, the saturation of air. Before that, we talked about the entire aspect of relative humidity and how it reaches saturation. So, saturation is basically when the relative humidity reaches 100%. Okay, so here when we talk about again dew formation, let's take another example. Now, let's suppose an air parcel is at a temperature of 40 degrees Celsius across a coastal area, let's suppose. And here, the in the coastal region, let's suppose at 40 degrees Celsius, the carrying capacity. Again, I will have to repeat the entire concept. So that is all of you who have missed out. See, this is why I want you to be attentive from the first part of the session. Many of you end up joining significantly late, and that is why we keep on lagging behind in the module also. So please pay attention right now. Okay. So here, let's suppose the carrying capacity is 10 grams, or let's say 15 grams. Let's suppose moisture present is 10 grams. Now, in this case, what will be the relative humidity? Okay. Suppose I cool it down. Now, after cooling it down, let's assume I cool it down to 30 degrees Celsius. So from tomorrow, I won't be doing this, guys. It is today that I'm repeating the entire thing, but tomorrow, from tomorrow, if you end up joining late, please have that minimum decorum that you start watching the recorded videos. Please don't have the entire session go through the entire repetition itself. Okay. So here, when we cool it down to, let's say, 30 degrees Celsius, carrying capacity would reduce. Carrying capacity, let's say, will reduce to 12 grams. Moisture present is same. Is 10 grams. What will be the relative humidity? How much will be the relative humidity? Good. How can it be 120, my dear friend? 10 by 12 into 100, how will it bring you 120? Please understand, you have to clear the CSAT exams in order to appear for the mains and then appear for interview. First of all, you have to clear the CSAT. Approximately 83%, we can say that, isn't it? Now, if you want a further explanation, if this is also, let's suppose, not understood, so this will be 10 into 8.33, that will be 83%. So what is happening with the cooling? Relative humidity is increases with cooling. Is that understood? So all those who were asking about relative humidity increasing, why relative humidity is increasing with cooling, now I hope that is clear. Now, after that, let's suppose I carry out further cooling. Let's suppose I reduce, or due to cooling at night time temperature, etc., temperature reduces to 25 degrees Celsius. In this case, let's suppose the carrying capacity of the air is 10 grams. Moisture present is 10 grams. Moisture present is not changing because let's suppose there is no fresh input of moisture. That is why the moisture present is consistent. So in this case, what will be the relative humidity? 100%. Can the air accommodate any amount of moisture anymore? No, right? Air cannot accommodate any amount of moisture. So can we say this air is saturated now? Air is saturated. It cannot accommodate any amount of moisture. So can we say that 25 degrees Celsius is the dew point temperature of the air here? We can say that. So dew point temperature is how much? 25 degrees Celsius. We can say so. So let's suppose when we talk about cooling the air even by 2 degrees Celsius, if I reduce the temperature even by 2 degrees Celsius, I take it to 23 degrees Celsius. So in that case, what will happen? There is going to be what? Significant amount of condensation, isn't it? Condensation will happen. But will there be ice formation in this case? Or will there be liquid water droplet formation in this case? Can ice be created at 23 degrees Celsius? Samiksha and Karthik, can we have ice formation at 23 degrees Celsius? No? So here, what do we have? Condensation. That means dew formation. Right? So here dew formation takes place at what temperature? 23 degrees Celsius itself. In this case, the dew formation was happening at, in certain cases, it was happening at less than 0 degrees Celsius. But why? So if the moisture present in the air is very less, then it takes a long period of time for the air to get saturated. When the moisture present is significantly higher, the air gets saturated very quickly. Is that understood? So if the moisture present in air is high, means saturation will be reached easily, is reached easily. Saturation is what? The carrying capacity. So if already the moisture present is very high, means slightest reduction of temperature will take you to that carrying capacity. That is why saturation is reached easily. Is that understood? Or is there a doubt which still prevails? Understood? Good. Dew formation happens because of condensation. All those who have a doubt that what is the difference between condensation and dew formation, there is no difference. Does not mean that whenever condensation happens, you say that this is dew. Condensation can happen at various levels. When the condensation happens on the surface, that is when dew or frost formation takes place. Otherwise, condensation eventually can lead to cloud formation as well. Okay, is that understood? Dew is a type of condensation, yes. Okay, so here when we say basically if the moisture or if the air is dry, that means saturation. For saturation to be attained, air needs to be cooled down quite significantly. Is that understood? Right? So if the air is dry, means the moisture present is very less. So that is where it requires to be cooled down quite significantly. Any doubt that prevails up till now? Any doubts? Basu, I already told you that when we refer to a pack of parcel of air, there is no dimension to it. It is just a sample or an example that we take. If I take cold water bottle and put it in water which is at room temperature, will there be condensation occurring? Yes, there will be condensation happening. Is absolute humidity is directly proportional to relative humidity? It is a measurement. It is a different measurement. It is like asking, is the weight directly proportional to mass? So yes, you can say it is. In real life situation, is it possible to have the same moisture in any particular region that you are living? Can you have two different wherever you are right now, you will have one temperature or two temperatures? In your room presently, it might be 24, 25 degrees Celsius. Or will it be that in your room simultaneously you have 45 degrees Celsius or 25 degrees Celsius simultaneously? You will have one temperature. So in the room that you are sitting in, you will have the some amount of moisture present. Now, will that be same at a point of time, or will that be in multiple different dimensions? Himani, do we consider absolute humidity or relative humidity in the case of saturation? My dear friend, what is meant by relative humidity and absolute humidity? Is that understood first? Both of them, they end up measuring the amount of moisture which is present. Both relative and absolute and specific, or rather all three of them, they are just a measurement of the water vapor which is present in the air. And in absolute humidity, we measure the weight of the water vapor. In specific humidity, we measure the weight in respect to 1 kg of air. In relative humidity, we measure that what is the water vapor present in comparison to what the air can hold at a point of temperature. So you, in all the three things, you are measuring the amount of moisture which is present. Okay. When temperature is 0 degrees Celsius, there is dew point, but in dew formation, there is dew formation is 20 degrees Celsius, 23. Nancy, both the examples that we have seen earlier, 0 degrees Celsius and 23 degrees Celsius, both of them are different cases. Both are not the same temperature. Both are not the same conditions that we are taking. Does rate of saturation is directly proportional or inversely proportional to condensation? What do you mean by rate of saturation, Supriya? What is meant when you are referring to rate of saturation? First of all, let me know that. During winter season, what happens appears on the spectacles while wearing a mask. That is also condensates. In dry region to witness rainfall, is this portion understood? That means relative humidity is 100%. That means dew point is attained. Yes. Okay. So that what it means is that in drier regions, dew formation happens at very low temperature. For example, that is the reason that in the region of, let's say, Delhi, Chandigarh, Ambala, etc., you will experience dew formation only during winter nights because these are drier areas, so they need to be cooled down quite significantly. In moist areas, in moist areas like the coastline or rainy season, dew formation can happen at higher temperatures. Higher temperature. When the dew point temperature, dew point is 0 or less than 0 degrees Celsius, there is formation of frost. Okay, that is about dew and dew point. I hope now this is understood. Now we come over to the portion of cloud formation. How is it that the cloud formation takes place? So cloud formation is again a resultant of the process of condensation happening. Here the condensation is happening at a greater altitude. Condensation is happening at a significant height. Okay. So why will the cloud formation happen? So when we talk about the cloud formation, so they are defined as aggregates of innumerable tiny water droplets, ice particles, or a mixture of both in the air, generally much above the ground surface. So here when we talk about it, let's suppose we consider a particular surface. Let's suppose we consider a surface here. Okay. Now in this case, any air parcel, and by air parcel, I don't mean a kg of air or a meter cube of air. Air parcel, I'm just taking as an example, some air, okay? Any sample of air, whichever volume or whichever mass you like, take that mass itself. Whichever is your favorite volume or for your favorite mass, if you have any, take that as an example. Just understand an example of air is what I am considering here. So if I consider an example of air here, now in this case, let's suppose this air has got warmed up. So this will rise. After warming, the air rises up. I hope I don't need to explain all of that again. So after warming, the air rises up. It can happen anywhere where there is heating. So as the air rises up, what will be the change in temperature? Will it heat up? Will it cool down? Will the air heat up or will the air cool down? It cools down. Good. So the air cools down. All those who have said heats up, kindly take a revision of the previous session, my dear friends. I request you, please take a revision of the previous sessions. Otherwise, I don't know how are you going to deal with the portion of frontal formation and tropical cyclone. Again, I will tell you, again, I will repeat to you, please understand this is not your typical subject of history or polity where you just attend the session, you chillax at home, and in session also you have not understood, you relax at home, you miss 2 or 3 classes, fourth class you come in again, that okay, fair enough, there is something that I will understand. That is not how it goes in geography. Okay, geography, in that each subject or each topic is interrelated to the other one, it forms a chain. If you follow that chain, this subject will come to you. If you are missing out on the important links in between, trust me when I say this, try everything that you can. You will never be able to understand the subject. Okay? So please have that kind of an understanding. The previous slide, all those who were asking for the previous slide, here is the previous slide. Take a screenshot if you want. Now, we are taking wind or air as air parcel. What else do you want to take? I will not talk about air parcel. If air parcel is the term air parcel confusing to any of you, what is the confusion with the term of air parcel? Please let me know. What is the confusion that you have with air parcel? Is there any other word that I can use which will be much more helpful for you? Can I always say some amount of air? Will that be more helpful? A part of air? Okay. Okay, let me write it down. Air parcel, part of air. Any sample of air. Any size of air. Any volume of air. Is that sufficient for you guys now? Or is there a doubt which still prevails? Okay. So when the air rises up after warming, it gets cooled down. Now, after cooling down, it generally it will rise up till the point that it is warmer, the surrounding, it will continue to rise up. But as it continues to rise up, it will cool down. As it cools down, rises further, it will cool down further. So there, after rising up, it reaches saturation. Because of cooling down, it will reach saturation. So if it rises any further, it will cool down significantly, right? So in this, again, as it rises up, it will cool down again significantly. So when it cools down beyond the point of saturation, what will happen? Condensation will happen. So condensation will always happen around certain particles itself. So this is where the role of dust particles come in. This is where the role of dust particles, they do come in. Now these dust particles, they will provide a surface for condensation. Now by this height, let's suppose in order to reach saturation, the air had to travel for, let's assume 6 kilometers. Let's assume again, I am saying, so before you ask the question that how did you come at 6 kilometers, why 5 point, why not 5.9, why not 6.1, I'm assuming, let's assume that in order to cool down beyond the point of saturation, it takes 6 kilometers. Let's say that at a height of 6 kilometers, the temperature is minus 10 degrees Celsius. So here when the condensation will happen, will you have liquid droplets or ice particles here? Ice particles? Good. So here when you observe these ice particles, they will start developing on these. So condensation which will happen around these dust particles, all of them. Small, very tiny droplets of ice. Very, very tiny droplets of ice. Now tell me one thing. These droplets or these tiny particles of ice, not droplets, but rather tiny particles of ice. These tiny particles of ice, and think about it very carefully. Apply your logic, regardless of whether you have understood the previous portion or not. Just listen to the further few minutes very carefully. Apply your general logic. The ice particles that I told you, their size are very, very small. But will they be considered to be a kind of a surface? Yes or no? They will be considered to be a part of a surface because they will also have a surface regardless of whatever their size be. Their size might be microscopic, their size be maybe for a few millimeters, but they will be considered to be indicating a surface. Now, will that, no, dry ice is carbon dioxide, that is different. So when we say that surface, now that surface of ice particle, will it have low temperature or high temperature? Will it have low temperature or high temperature? Very low temperature. So, further, for further air which continues to be pushed up, that ice particle will serve as a surface for further condensation to happen. It can happen because it is a cold surface, so air gets in touch with it. It again cools down, forms a larger ice particle around it. I hope we are able to imagine this, right? So, slowly and steadily, there will be much more condensation happening around it. Significant more amount of condensation happening. So on every surface, much more condensation will slowly happen. Eventually, accumulation of all this will lead to a kind of a cloud formation. Will lead to a kind of a cloud formation. Accumulation of all this. Why so much of concentration? Because that is where the air continues to rise up. Air has got water vapor. Air rises up. All that vapor, when it reaches saturation, all that vapor will start condensing. That is why, and it is not as if only 1 kg of air has risen and then the system has come to an end. It is a continuous process. So it will continue to rise up. Till this point, is it clear? I'll come to why the cloud appears black, why it causes thunder, lightning, why it causes rainfall, why it causes snowfall. I'll come to all of that. Till now, is this understood? Yes. So if no dust particles, there would not have been any cloud formation. That is correct. So till now, I hope it is understood. Good. Let's take it step by step, guys. Let's not jump ahead of ourselves. That is when confusion happens. So this is a kind of a cloud formation. So that cloud formation after dust particles. Okay. So these dust particles which are present at a height of 5 kilometers, 6 kilometers, 2 kilometers, 3 kilometers. So these dust particles will be colder in terms of their surface will be colder. So when the air rises up, gets in contact with the cold surface, there will be some condensation happening, isn't it? So that is why their condensation happens around these dust particles. That is why these dust particles which attract or which allow the condensation to happen, they are referred to as hygroscopic nuclei. Something we discussed in the first class of climatology. That dust particles, they play a significant role. They provide the surface for the cloud formation to happen. This is not a dew formation. Dew formation will happen on the surface. This is the cloud formation. So can we say that this cloud formation is something which is, or this cloud in itself is, can be contained of ice particles and cool down liquid water droplets? Will that be a correct statement to make? That this cloud is consisted of the ice particles and many of the super cooled water droplets which have condensed at that greater height? Perfect. Now, slowly and steadily, they will grow larger in size. More condensation will happen. Each of these particles will grow larger in size. Till this portion, it is clear. Why vapor in the air directly converted into ice? Because the temperature is minus 10 degrees Celsius, my dear friend. It can happen that the saturation is attained at a negative temperature as well. Saturation need not always happen at a positive temperature. If saturation happens at negative temperature, then further cooling down, that is what will lead to the formation of ice particles. Is that understood? Right? Good. Now, after this, dust particles is present at every height. Then why cloud appears at proper height? Cloud also appears at every height. Cloud formation can happen at 13 kilometers as well. It can happen at 2 kilometers as well. It depends upon the region. It depends upon the various conditions. Is that understood? Now, these dust particles around which the condensation is happening, that is why they are also referred to as the condensation nuclei or the hygroscopic particles. Now, after this, we come to the occurrence of rainfall. So let's suppose you have a cloud formation somewhere here. Now, this cloud is consisted of various different ice particles, various different dust particles, let's assume. Now, will this block sunlight or will this allow the sunlight to come through? If the particles are very densely packed with each other, they will block some amount of sunlight. So from top, all the sunlight which is received, significantly it is reflected. So here they will trap the sunlight. So what will be the color that you look at it from below? Won't it appear darker? If the sunlight is blocked, won't this appear darker? That is why thick clouds from the bottom, they will appear very dark, just purely because they are blocking light. That is it. It has got nothing to do with that this kind of a particle is trapped or that kind of a particle is trapped. It is purely because they are trapping or they are basically reflecting the light. They are not allowing the light to pass through. Okay. Now, here the particle size grows larger and larger slowly. Either ways, when if ever you have or whenever you get an opportunity next time to travel through an airplane or an aircraft, take a look at the video itself. Now you will see that the aircraft is able to move through the clouds. It is not as if it is that solid that the aircraft hits the clouds and crashes, because these are multiple different small particles kept together. So that is why when an aircraft passes through a cloud, you will sometimes hear some amount of clinkering sound. That is as these small ice particles will hit your aircraft. Okay, that is created by these small particles. So slowly and steadily, more condensation will happen over a next couple of days or over a next couple of hours. This will grow larger in size. As it grows larger in size, its weight will increase. It will become so large that it will start dropping. So this ice particle starts to drop. Now, as this ice particle starts to drop here, for this ice particle, as it is coming down, will it experience an increase in temperature or a reduction in temperature as it is coming down from the higher elevation? Will it experience an increase in temperature or decrease in temperature? Very good, significant increase in temperature, because the temperature is higher on the ground surface and the temperature is lower higher up. So as it starts coming down, it will experience an increase in temperature. So that is when these ice particles, they will melt into liquid water droplets. And these liquid water droplets that fall, that is what we experience as rainfall. Now, I'll tell you about snowfall separately as well. But is this portion understood? That why is it that rainfall happens? Is that process understood? Very good. Now, sometimes what happens is, let's suppose in certain areas, for example, where we experience snowfall in some reaches of higher reaches of Himachal Pradesh, in Jammu Kashmir, in Ladakh, in some reaches of Sikkim, in some reaches of Uttarakhand, and in some reaches of Arunachal Pradesh. That's it. In India, we receive snowfall only in these areas. So in some areas, what happens is that the ground temperature, let's say, is below freezing point. Ground temperature, let's assume any of the assumptions that you take, below freezing point, let's say minus 2 degrees Celsius. So that means the air temperature here will also be minus 2 degrees Celsius. So in this case, what happens? Let us understand. The ice particles have started falling. These ice particles, as they encounter initially a higher temperature, they will melt into liquid water droplets. But as these liquid water droplets are falling, suddenly they encounter a very low temperature. That is when there will be refreezing into multiple small snow particles. Right? And that is how you receive snowfall. So when the temperature is very low, in that case, you have water droplets refreeze into snow. That is when we receive snowfall. Is that understood? Good. Is there any doubt which prevails till now? Sometimes snow also falls from the cloud. So ice particles fall from the cloud, they melt, and if the temperature on the ground surface is below freezing point, that is when they will refreeze. And that is what we refer to as snowfall. Is that understood? How pieces of ice rains with water. That is different. That is hailstorm. That is something we'll talk about it. That is hailstorm. Okay. We'll talk about hailstorm, guys. Is that understood till now? Good. Which temperature droplet refreeze into snow? When below freezing point. Will air crashes happen when traveling through clouds? No, it does not. It does not happen. So this is understood now? Okay. So let's take a break now and let's be back, and we will continue with the portion of thunder, lightning. Then we will talk about hailstorm, cloudburst, etc. Okay. So now we take a break and we'll be back in at around 7. Okay. We have a cloud formation here. Now, let's suppose this is the ground surface. Now, in the clouds in general, you will have lot of various different ice particles. They will be present in significant quantity. When the particles they rub against each other, they develop a charge. In general, whenever you have particles rubbing against each other, they will end up developing a charge, isn't it? So, for example, if you have conducted that experiment in your class 6 level where you have, let's say, a plastic scale, and then you rub it against a woolen cloth, it develops a charge, because whenever you have the particles rubbing against each other, they will end up developing a kind of a charge. So whenever you have various different ice particles and the dust particles included within them, when they rub against each other, they will end up developing a kind of a charge, right? So let's assume a particle from here, it starts dropping down into the lower portion of the cloud. So as it starts dropping down into the lower portion of the cloud, it will keep on accumulating charges from all around. Charge is what? The gaining of electrons. So by the time that the particle reaches to the lower surface, it would have gained sufficient number of electrons in the process. So here the lower portion of the cloud will end up developing a kind of a charge. Development of charge. Due to the movement of particles with respect to each other, that is why you have development of charge. Rubbing of particles against each other, that is why you have development of charge. Now charge always flows from negative to positive or negative to zero, always, because charge is what? Electrons. So electrons will always flow from a surplus to deficiency. So charge always flows from negative to positive or negative to zero. Ground surface always is considered to be reflecting zero charge. So ground surface, when we talk about, ground ends up representing zero charge. Now here, if basically, let's suppose you have a large tree or a large building for that matter. Let's suppose you have a significantly larger tree. Now, that tree will also be a kind of a projection of the charge of the ground itself, because that tree will also end up indicating zero charge. It is connected to the ground. Anything which is connected to the ground generally ends up indicating zero charge. That is why when you walk bare feet and you touch an electrical line, that is why you get the shock, because you are also connected to the ground, so the charge will flow through your body. That is why we receive electrical shock. So this also represents zero charge. Now that is where sometimes what you will observe is that there is significant amount of flow of charge. There will be a sudden movement or flow of charge. And that is what we experience as lightning events. Now, whenever these lightning events happen, you have huge amount of charge in the terms of many kilovolts, thousands of volts, which end up moving in a very short span of time. In a very small span of time, huge amount of charge indicates a kind of a flow. So in that situation, what do you gather? In that condition, you will have huge amount of charge which passes through. So that is where you will always find out that whenever you have events of lightning, people actually, when they succumb to that lightning, or people, whenever you have casualties due to lightning, it is that people get burned to death, right? because that high amount of charge, when it flows, there is a very high amount of heat which is produced in the process as well. So that is where you will have the movement of lightning. I will repeat this again and listen to this carefully this time. When we talk about a cloud will have various different, numerous different particles. Now, whenever you rub the particles against each other, they tend to gain or lose electrons, right? Suppose you have a particle, another particle is coming there, rubbing against it. It might take an electron from that particular particle, it might develop a charge. So whenever you have rubbing of various different particles, they might develop a charge. So as the particles in the cloud, they keep on moving because of the air movement, etc. That is why the clouds will develop a charge. So this development of charge in the clouds that happens is because of the movement and rubbing of the particles against each other. So when they happen, that is when you will have basically the acquirement of a charge. So when that charge dominates, that is when, whenever you have the charge dominating, so the ground surface is zero charge. So that is when a charge suddenly flows from negative to zero, and that is what we experience as lightning. That is why it is always suggested that whenever you have very dense clouds and if it is raining, never take a shelter underneath a tree. In major every year in our country, we have couple of hundreds of people who lose their lives because of this lightning event. Because oftentimes you will observe, where is it that the lightning strikes? Either on top of a particular building, which is a projection of the ground itself, or in large open farmlands, where in between those farmlands you have one or a couple of very large trees. So that is where you will observe the movement of charge. So when if suppose you have taken a shelter underneath that tree, immediately you will be burned to death. That is why whenever lightning occurs, everyone who takes shelter, or if a lightning strikes on a tree, trees are ideal cases where the lightnings will strike, or the buildings are the ideal cases where the lightning will strike. And that is why always recommended, it is better to get drenched into the rain rather than taking a shelter underneath a large tree, because in that case chances are, if a lightning strikes, there is nothing which can stop you, because suddenly you will have such a high amount of charge flowing through your body that your body's temperature for a brief moment can rise for many degrees Celsius, and you will be burned to death. So this is the case of lightning. Okay, so this is lightning. Okay, now here, when we talk about this event of lightning, always whenever lightning occurs, majorly you will observe that sometimes you would also have observed that it is not always that lightning hits the ground. Sometimes you will observe there's a lightning in the sky itself, right? So sometimes it can also happen that you have development of charge within the clouds, and the lightning can happen within the cloud itself. That is when you observe the clouds experience lightning themselves. So around 80% of the lightning happens within the clouds itself. Only around 20% of these lightning events, they happen within the cloud and from the cloud to the ground. Okay, so here, but whenever this lightning happens, there is also a significant amount of sound which is created, a thunderous sound. Now, why is that sound created? So basically, that sound is created. Let's suppose you consider the air around this. Lightning falls on TV. When is it, my dear friend, that lightning has fallen upon TV? It cannot happen unless and until you keep the TV outside with the antennas raised. Have you ever experienced lightning on the TV? Never, I don't think so. So, inside your house, lightning can impact the television network. But have you ever seen that lightning has uh, come inside your room and then it has impacted your TV? In the case of TV towers, in case you keep the TV outside, there also lightning can strike, because there also you have the movement of charges. If you ever observe the working, or if you ever understand the working of the television sets, they also work upon the movement of charges. Okay. So here, why is it that we experience thunder, the thunder sound? So that thunder sound which is created is because as such high amount of charge passes between the cloud and the ground surface, or any place for that matter, in this parcel of air immediately around it, would you experience a rise in temperature? Yes. So in this case, in the air immediately around it, sudden rise in temperature is observed. Okay. Sudden rise in temperature is observed. Now, when you have the sudden rise in temperature which is observed, due to that, what will happen? Due to that, you will have what happens when the air temperature rises. Air expands, but here the temperature is rising very suddenly for a very short span of time. So you have sudden and violent expansion of air. Sudden and violent expansion of air. And that sudden and violent expansion of air, that will produce the sound that you experience as thunder. Produces thunder. Lightning can strike at electrical transformers. Yes, if there is no proper grounding and lightning conductors which are there, it can always strike any of those. That is why large buildings, you will always observe that whenever you take the case of very large buildings, tall skyscrapers, etc., in all these cases, you will observe they have a lightning conductor present. And that lightning conductor is basically a protrusion here, a kind of a tower of sorts, and that conductor then goes underground, so that in case there is a lightning strike, that charge passes through the conductor and reaches the ground. So it provides the safe and a faster passage of the movement of the charge without impacting the inhabitants or the inhabitants of the building. That is what is referred to as a lightning conductor. Okay, right? Is that understood? Good. So that is basically the aspect of thunder and lightning. Yes, lightning arrestor, lightning conductor, anything that you use. So when we talk about thunder and lightning, it is thunder or lightning is rather created when you have the very dense clouds developing a charge and you have the flow of charge from the cloud to the ground surface. Okay, right? Now, when you have this lightning which flows, suddenly there will be an expansion of air, violent sudden expansion of air, that produces significant amount of sound, that is thunder. Why it impacts Tata Sky while operating? That is because, my dear friends, understand, when you have whichever portion that you are operating, whichever dish TV you are operating, they work on the emission of signals, emission and reception of signals. So those signals get interrupted whenever you have very dense cloud and these lightning strikes, etc. So the signal movement that gets interrupted. Okay. So is that understood? Good. Okay. If why there is thunder without lightning, there is never going to be a thunder without lightning. It is the thunder that you hear, in those cases you are not able to see the lightning. That is where, so lightning might have occurred here You might not be able to see that because of the density of the clouds, but the sound is something that you will hear. The land is zero charged. Always land is zero charged. Okay. building building part. So whenever you have any projection from the ground which ends up having the zero charge as well, any projection which anything which is in contact with the ground, that will also end up projecting a zero charge. So when you have very tall buildings, they are just a mere projection of the ground charge itself. So that is why it can be prone to lightning strikes. That is why the buildings have the presence of lightning conductors and lightning arresters. This is what is lightning conductors. Okay, that is what we refer to as lightning conductor and arrestor. Okay. Why everyone tell don't use internet at time of lightning? So those are older concepts, my dear friend. So those are older concepts when you had, and please don't stop using internet because of that. So because it was of that kind of a condition where, remember, or I'm sure many of you would not be aware of that, that earlier you had a situation where you had one cable operator and they would transmit that signal with the help of wires to your TV directly. The older TVs, the older large dish antennas that only few people had, and they would be connected with wires. So if you had a lightning strike on that antenna, that would get transmitted through the wire, and it might have impacted your TV. Or in case of the earlier one, the Ethernet cables, so that is how it could have impacted. If you are connected via Ethernet, it could have impacted your systems, your laptops, etc. Okay, is that understood? Right. But sir, thunder occurs due to collision of clouds now. How is that it can happen? Who told you this? So many of us, we have gained so much amount of preconceived notion from earlier itself. So it is not as if that thunder will occur due to the creation of or the cloud. Clouds are made up of very small ice particles. If they will collide, can they ever end up producing that much amount of sound? Absolutely not. Okay. So all these myths which prevail, that basically, let's suppose you need not wear dark colored clothes or lightning will strike, etc. All these are various different types of myths prevalent. Okay. Thunder is where you have lot of charge which passes through in a very short span of time. Okay, sometimes clouds are there on sky but not happened continuously. So not every cloud will have the development of this kind of a charge process. Okay. Avni, my dear friend, we are already behind many different modules. So thunder or lightning, which reach the earth first? So think about it, which travels faster, light or sound? Which is it that it will travel faster? Light, always. So always light, sound. Light has got a greater speed. So that is why lightning is something which will be observed first, sound follows later. Land is always zero, my dear friend. Always. That is why you refer to earthing. Okay. Why keep iron rod in front of home during lightning? Try try doing one thing. Don't keep the iron rod in front of your home. See if anything adverse happens. It never happens like this. It doesn't operate like this. A one small iron rod in front of your house can never prevent you from lightning if your house is not having a kind of a lightning conductor or arrestor. If the thunder has to strike, yeah, or if the lightning has to strike, it will strike. Okay, a small piece of iron rod will never help you. Okay, now the safest place in the case of lightning is always a moving vehicle. If you have a moving vehicle, that is the safest place in case of lightning, always. A moving bus, a moving car, that is the safest place because that follows what is referred to as the Gauss law, which you don't have to know at all. So that is where the charge accumulates only on the surface of the vehicle. Okay, and the charge is not something which comes inside. So here, when we talk about the various different clouds, so clouds basically, they are formed at different heights, and there are various different classification of clouds. Even in your day-to-day lives, you would have observed that sometimes clouds are much closer to the ground level. They are very, very thick, very dense. They appear very dark. Sometimes clouds are present at a greater altitude. So that is when you observe that there is no rainfall which is caused. Clouds have different shapes that you would have observed. So you have a variety of clouds. Overall, if you go for the classification, you will find that in total there are 10 different types of clouds in general, if you want to classify. But the basic aspects of clouds here, when we talk about, so clouds are of certain types. So you have what is referred to as stratus. Stratus is basically, stratus is again taken from the term strata, meaning layers. So when you have layering, which is present, when the clouds are present in large horizontal layers, that is what is stratus, not stratosphere. Clouds present in horizontal layers. Then you have a type of cloud which is referred to as cumulus. What do we understand by cumulus? Cumulus represents an accumulation. So here you have, let's suppose, a kind of a cloud formation somewhat like this. So this is what is referred to as cumulus, where you will find it is a kind of a vertical development which happens in the cloud. Then you have another category, that is cirrus. Cirrus refers to very high altitude clouds. Very high altitude clouds. Then you have what is referred to as nimbus. This represents rain-bearing clouds, which will actually cause rainfall. So rather than learning all the various different types of cloud formation, I would rather suggest to you apply your logic that clouds are classified into high level, mid level, low level, and then multi-layered. So high level clouds, they will always have a name cirrus or cirro associated. So here, if at a high elevation you have a layered formation, that is cirrostratus. If at a high level you have accumulation in heaps of, such as balls of cotton, they will appear, cirrocumulus. If at a high level you just have a random distribution of clouds, cirrus. Then in the mid level, you attach the prefix alto. So you have altostratus and altocumulus. Then in the low level, you have individual of them, that is stratus, cumulus, and also stratocumulus. Stratocumulus is a combination of stratus and cumulus. So how will the combination of both of these look like? So this is where you will observe the formation somewhat like this. That is your a combination of both of them. That is stratus as well, cumulus as well. So this is stratocumulus. Okay, and then you have certain clouds which are multi-layered, which can have their formation right at the around 2 kilometers from the ground surface, and they can extend for many kilometers in thickness. The ones which appear very dark and which cause significant amount of rainfall. So you can have nimbostratus and cumulonimbus. So here you have a kind of a schematic representation of the same. So if you will observe here, you will observe that the high altitude clouds, they are either cirrocumulus, cirrostratus, or cirrus in themselves. Then you have the mid-level, that is altocumulus and altostratus, right? So at mid-level, if you have a horizontal spread, or at mid-level, if you have, let's say, accumulation, that is altocumulus. Cirrus and alto level clouds, they will rarely bring you rainfall. In general, they will not bring you rainfall, because in the case of cirrus, by the time that even, let's say, there is some amount of ice particles which melt and which fall, the height is so much that before falling on the ground surface itself, it will re-evaporate. So that is why cirrus and alto, they will barely bring you any amount of rainfall. Then after that, you have cumulus, stratocumulus, which is a combination of them, stratus, but the most dangerous of them all is the cumulonimbus, which is a cumulus, but it is spread across multiple different layers. So it is spreading across many kilometers. All the thunder, lightning, very heavy rainfall you will experience in this case. Then you have nimbostratus. Nimbostratus is like a layered formation. It will appear very dark. Within it, it can include many different cumulus clouds themselves. And then this brings rainfall, but a prolonged and continuous rain. This brings you a short span of very heavy rainfall, violent rainfall. This will bring you a kind of a prolonged rainfall. So sometimes you would have experienced that it has started raining around 2 p.m. in the afternoon. It continues to rain, and it will continue to rain without much thunder and lightning. It will continue to rain with darker clouds up till 10 p.m. at night or 11 p.m. at night. That is caused by nimbostratus. Whenever you have cumulonimbus, immediate lightning strikes will occur, violent, very heavy rainfall, and it will rain maybe for a couple of hours, and then it will give you some amount of relief. Okay, so that is basically the different types of clouds. So let us take a look at few of them. So cirrus. So cirrus clouds, they appear like this. So these type of cloud formations that you observe, that is what is referred to as cirrus. Do we need to remember these names? If you try to remember these names, you will never be able to remember these names. Better you understand the naming of it. If you understand the naming, you will never be required to learn this. So understand the naming: high altitude, cirrus or cirro; mid altitude, alto; low altitude, stratus, cumulus, stratocumulus; and multi-layered, nimbostratus and cumulonimbus. So these are your cirrus clouds. They will have the unique, very thin, feathery, wispy appearance. So you will observe feathery, wispy formations made up of very minute ice particles. They are often colored in bright yellow or red before sunrise and sunset, respectively, and they light up long before other clouds and fade out much later. That is because of the interference of light and refraction of light, which creates this phenomena. So that is refraction of light. Refraction of light, which creates this phenomena. These will barely or rarely cause any precipitation. Rarely they will be able to cause any kind of precipitation. Then you have cumulus. Cumulus clouds appear like this. The low altitude clouds that you have, they will have an appearance like this. They will have a development vertically. They will have a kind of a vertical development. This is the result of evaporation that you observe. So it is a thick low altitude cloud, usually puffy and have a vertical development. They look like heaped up cotton that you have, right? Like balls of cotton, found everywhere in the world except for the polar regions. Why? Because in polar regions, you don't experience any kind of evaporation. So that is why everywhere you have any kind of evaporation, you will find these kinds of clouds formed. Then you have stratus. They are a long horizontal cloud formation. They will not appear very dark. They sometimes you would have seen clouds which are there, which are whitish as well, which are brightish as well. So they are not very thick, but they are horizontally spread. So that is where they sometimes cause light mist or drizzle, that is very light amount of droplets of rain, in which you can walk outside as well, but you feel some amount of droplets which get created. That is basically the stratus. Okay. Now, then we come to the portion of the multi-layered cloud, such as nimbostratus. So this is what your nimbostratus appears to look like. It is very, very thick. Not as thick as a cumulonimbus, but this is spread in layers. And that is where within itself as well it can have cumulus formations. So in these areas where you have cumulus formations, light will never be able to penetrate through. So that is why these regions will appear very, very dark. In certain areas where the light is able to penetrate through, you will observe the brightish formations. Okay, brightish formations. And in certain areas, very dark. So that is your nimbostratus. So these are low clouds, and they are multi-layered clouds as their vertical extent might very well go into the middle cloud region, and they often have taller cumulonimbus clouds which can get entrapped within them. So this causes continuous moderate rainfall. Moderate rainfall. Okay. And here it is in these clouds where you will oftentimes come across the lightning happening within the clouds. That is a common phenomena. So in many of the cases, you will observe lightning occurring within the clouds. Within the clouds themselves. That is what is nimbostratus. Then you have the most dangerous and the most violent of them all. That is what is cumulonimbus. So they will always produce lightning, thunder, heavy rain, even hail, etc. that we will see. So all of them. Now, this will basically be most common. It will be most common during the afternoons of summer and spring, when you have significant amount of continuous evaporation, when you have a lot of evaporation and condensation which happens. That is when cumulonimbus is created. This creates very heavy rainfall along with heavy lightning and thunder. Significant amount of lightning and thunder will be created by them. Okay. Then we come to what is referred to as a cloud burst. So as you can see here, cloud burst is when a cloud simply gives way. When a cloud becomes so unsustainably large that it is not able to sustain itself, it is not able to hold itself, it will suddenly give way, and all that it is holding will immediately be dropped in the form of significantly heavy amount of rainfall. That is cloudburst. So in the cases of cloudburst, you have excessively large amount of rainfall received in a short span in a shorter area. So a cloudburst is localized but intense rainfall activity. Rainfall of 10 centimeter or more in an hour over a roughly 10 by 10 area is classified as a cloudburst event. So this happens when the cloud goes or grows unsustainably large. So this will generally happen in the case of cumulonimbus cloud formation. So generally in cumulonimbus cloud formation. Okay, that is when, or that is where it will be experienced. Now this is experienced in hilly areas. majority of the cases, or majorly in hilly regions, and then sometimes in plain areas, which is a very rare occurrence. In plain areas, it is not a common occurrence. So, why does it happen? Let us understand that process. So, for example, let's suppose you consider a hilly or a mountainous area, hilly or a mountainous region, let's suppose. Now, in this case, if you have winds which are consistently moving, let's suppose monsoonal winds. Monsoonal winds will carry a lot of moisture along with them. Now, these monsoonal winds which are consistently blowing, they will be pushed up to the surface. Against the surface, they will be pushed up. Now, as they rise up, they will cool down and they will form a cloud. Here, on the windward side, they will form a cloud of sorts. Now, this wind, it is not as if it will immediately, one parcel has come or one sample has come and it will come to a stop. This is a continuous movement. So the clouds, they continue to grow larger and larger. So the clouds will grow much larger. And here the clouds will be kept floating in the sky. Can you think about the reason? Why, despite the fact that the clouds are growing larger and larger, still they will be kept floating in the sky? Apply your logic here. Very good, Pooja. Sakshi, correct. Kumkum, correct. It is because continuously the winds which are moving, yes, the winds which are continuously blowing, now those winds continuously will keep the cloud aloft. They will not allow the cloud to come down. So, as the winds are continuously blowing, the cloud will further grow much larger in size. The cloud continues to grow much larger in size. It is kept aloft by the wind. It will continue to grow much larger in size. Now, suppose even for a brief moment of time, let's suppose for a brief moment of time, you have the wind which comes to a stop or a standstill. Now, what will happen? Now, as this wind has come to a stop, then what will happen? Now, there is nothing which is there to keep the cloud aloft. There is nothing which is there to keep the cloud floating. So, suddenly, all that which was held will come crashing down. Huge amount of rainfall will be caused in the process. Huge amount of rainfall will be caused in the process. Very high volume of rainfall will be caused in the process. And because that high amount of rainfall will be caused in a very short span of time, that is why it can lead to flash flood events. And the Kedarnath disaster, which happened even in parts of Himachal Pradesh this year, all of them have been initiated by these cloudbursts. So, as the wind continues to move, it will continue to form the clouds, it will continue to build the clouds beyond proportion. The clouds will grow larger in size, and the continuous movement of the winds will keep the cloud afloat. If suppose for a couple of days the clouds or the winds they come to a stop, or for even for a couple of hours or some short duration, if the winds which have been keeping the clouds afloat, if they come to a stop, suddenly everything will come crashing down, and that is what you refer to as cloud burst. And that is what is received as lot of rainfall, it can end up creating flash floods as well. Now, in very rare cases, as you observe here, this can be observed over the plain regions as well. So, why is it that the plain regions experience this in rare cases? So, suppose there is intense heating of the ground surface, and that has caused sufficient amount of convection, very high rate of convection. And if there is a lot of moisture present in the air, all that moisture will condense to form clouds. So initially there will be similar process, a small cloud formation. As this continues, the cloud formation grows larger. As this further continues, the cloud formation will get further larger. It will keep on growing unsustainably large. Now, as long as the winds are there to basically, as long as the winds are there, they are present to keep it aloft. But the moment the wind disappears, let's suppose the wind disappears, then what will happen? Then, in that case, all of that will suddenly come crashing down. And that is what you experience as cloudburst. So in the case of hilly regions, because of the pushing of the winds above the hills, and in the case of the plain areas, because of intense convection. Okay, that is what we refer to as cloud burst. Now, then we have another such disaster, a kind of a disaster, which we refer to as a hailstorm. So, as many of you were referring to it, many of us generally confuse hailstorm with snowfall. Snowfall is very different. Snowfall is when snow occurs, and snowfall happens in the region. In India, snowfall is received only in Jammu Kashmir, Ladakh, Himachal Pradesh, parts of Uttarakhand, parts of Sikkim, and Arunachal Pradesh. Now, social media basically will report to you that snowfall has happened in Hyderabad also, in Bangalore also, in Delhi also. That is not snowfall. Sometimes during very heavy rainfall, you experience that there are large chunks of ice which fall. These are what are referred to as hailstones, and the entire event is referred to as a hailstorm event. Now, I'm sure in your regions also, whichever region that you are living in, you at some point of time or the other, you would have actually observed these hailstorms. Now, if you try to recall what was the weather condition during that point of time, you would have basically observed, or if you can recall, that there would be very dense, dark colored clouds, lot of heavy wind movement, and that is when this occurs. So these hailstone or hailstorms basically can have a potential disaster because these large chunks of ice, when they fall with a significant amount of force. They can shatter glasses, they can impact us as well, they can end up causing very serious injuries as well. So, in the case of a hailstorm to occur, there are two conditions which are required to be met. Only then a hailstorm will occur. Otherwise, a hailstorm does not happen. So, here, what are the conditions? First, dense cumulonimbus cloud formation. Cloud formation. And then you also have very strong vertical movement, which is also what is referred to as updraft. Very strong vertical movement of the wind. Okay, and that what you experience, what you observe is created due to intense low pressure. Okay, so let us understand this process. So, here, when we talk about these hailstorms, so let's suppose understand why it happens. Why oftentimes along with rainfall you receive these hailstorms? Why is it that you don't only observe the formation or the falling of the ice particles, or not only the raindrops, but oftentimes it is a mixture of them both? Even though many of us, we like to think that it is a kind of a snowfall, and you often hear people saying that, you see, this is like being in the hills or the hill stations, this is like being in Kashmir itself, that is how the situation is. But it is not at all similar. Hailstorms are very different than what a snowfall is. Snowfall are very tiny snowflakes, right? Being in a snowfall can be a pleasant experience, but being exposed to a hailstorm can be dangerous. Okay, so here, when we talk about it, so let's say we have a very dense and a thick cumulonimbus. Very dense. Few of the questions that I roll my eyes upon, they are so very interesting that it makes me wonder your understanding up till this age. But nonetheless, so here, when we talk about a very dense kind of, sir, please tell, when we see the sky yellow, pink, or little purplish after the sunset, it is because of the refraction of light. It can, that refraction of light can happen because of the dust particles as well. That refraction of light can happen because of the clouds as well. Is that clear? Okay. No. Okay. Jagdish, my dear friend, what is your doubt? See, I have been taking so many questions that we have been lagging behind quite significantly. So please don't have that query that I'm not taking questions anymore. Okay. Every day I'm spending at least 40 to 45 minutes on this question itself. What cloud seeding and how artificial rain was created? Artificial rain is also created. That is something that you will study in the portion of science and tech, my dear friend. Artificial seeding of cloud or cloud seeding is when, see, for formation of cloud, you need condensation nuclei. So when you, why is it that condensation nuclei is required for the condensation to happen? So sometimes when you don't have enough condensation nuclei in an area, with the help of an airplane or with the help of an artificial measure, you spray some amount of particles such as silver iodide, etc., and that allows the condensation to happen. So that is referred to as cloud seeding. It allows the condensation and the formation of cloud. Okay, so that is the aspect of cloud seeding. So in those areas, you can expect the occurrence of rainfall. Is that understood now? Or is there a doubt which still prevails? Good. So here, when we talk about these cumulonimbus cloud, so in these regions, when we talk about the intense low pressure, very intense low pressure is required. Low pressure. Now, in the region of very intense low pressure, the air will move up, right? This will be further pushed up. The air continuously will be pushed up. There is a continuous rise of air in this region. Now, let's suppose there is a small ice crystal falling from above. Let's suppose a small ice crystal falling from above. Now it is falling because it has become slightly heavier, so it is falling. Now, as it falls, gradually it starts melting sometimes. Then, in the process, it encounters this vertical wind or the updraft. So that is when this ice particle is again pushed up. This again pushed up. So when it gets pushed up, it will refreeze. It will start refreezing. It will accumulate or rub against the materials. It will accumulate more amount of vapor and more amount of condensate. So slowly and steadily by the process of refreezing, its size will continue to grow. Then as its size grows, again, it becomes heavier, it starts falling. As it falls, it will accumulate more materials around it. The size of the ice particle grows. Then again after that, it encounters these winds and again it is thrown vertically upwards. As it goes, it rubs against the supercooled liquid water, it rubs against the various particles. So the size of the particles in this refreezing continuously grows larger and larger. Eventually, it will grow such larger in size that it can no longer be held even by that vertical rising air. So when it grows significantly larger, that is when it starts falling. And that is when, even if some portion of it melts, but then there is still a large chunk which is unable to melt. That is how large it can grow. And that is what you experience falling on the ground surface. And these are referred to as hailstones. Okay. So these hailstones, they are created as a result of the multiple vertical movement through the region of the clouds due to the vertical movement of the wind, and that multiple and continuous rise and fall and rise and fall and rise and fall, that creates the increase in size, and that is how it ends up creating a larger sized of ice particle, and that is what is falling along with the rainfall. That is why whenever you have these hailstorms, you will experience that you have a very strong wind motion, because that wind motion is important for that multiple rise and fall of the ice particles. So that is basically a multiple rise and fall of ice particle. Multiple rise and fall of ice particles leads to refreezing, refreezing, and that ends up creating larger sized particles. Okay, that creates very large sized particles, which we refer to as hailstones. So these can occur generally during the late afternoons, around 4 to 5 p.m., when there has been a lot of heating which has been received, creating a significant low pressure in the summer months. Sometimes it is also to be experienced in the winter months, particularly in the western part of the country. In the winter months, you will never experience these hailstorms to occur in the eastern part of the country. Always it will occur in the northwestern part of the country. And that is because of creation of low pressure sometimes. You have the traveling low pressure systems during the winter, what we will study later as western disturbances. So those low pressure systems can also end up creating these hailstorms. Okay. Now, after this is a kind of a question which has appeared in prelims previously. So take this question. Appear as rising domes, classified as the force, won't they destroy the fruits? Answer is cirrus clouds are composed of ice crystals. Why the other statements are incorrect? Cirrus clouds have a flat base and appear as rising domes. This is incorrect. Which cloud has a flat base and appears as rising domes? Which type of clouds? You have the kind of clouds that we have seen, which has a flat base and which appear as rising domes, and that is stratocumulus. Then C, cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Just to show you how much attentive you are in the sessions. Cirrus clouds are feathery, wispy formations of minute ice crystals. So here when we talk about it, so this is not about cumulus, this is about cirrus clouds. Then cumulus clouds are classified as high clouds. This is incorrect. Cirrus are classified as high level clouds. Okay. Now, after this, we come over to the portion of types of rainfall. Now, the rainfall which is caused in different parts of the world, they can majorly be classified based upon the three types about how they are created or how they are caused. So you have convectional rainfall generally observed in the equatorial areas on a daily basis or generally observed in the marine regions or even the coastal areas or even in areas where there's a lot of heating, because this is a cloud which, or this is a kind of a rainfall which is created purely by evaporation and subsequent condensation. Orographic or orogenic rainfall or relief rainfall, which is created due to a physical boundary such as a hill, a mountain, a plateau, an escarpment, wherever you have a forced rise of the air. That is your orographic rainfall. Remember, in geomorphology, we had discussed anything associated with orography or orogeny is always associated with a mountain of sorts. And then you have cyclonic or frontal, that is created whenever you have a frontal formation. So when we talk about the types of rainfall overall, convectional rainfall. Convectional rainfall occurs generally in the late afternoons or in the evening when throughout the day you have experienced evaporation, and the evaporated material, they will end up condensing with a greater amount of height, and that is the convectional movement of air, hence the name convectional rainfall. So occurs due to the evaporation, due to convectional movement of air, and that is where we have evaporation and subsequent condensation. So this will be observed in the region of which areas? So this will be observed when we talk about it in the regions equatorial areas, coastal and marine regions, and then also in the regions having high heat. Of heat. So in these areas, whenever there is a significant amount of heating or whenever whatever causes huge amount of evaporation, that evaporation ends up creating very dense clouds. Initially, it can lead to the development of a cumulus cloud, and that cumulus cloud over a period of time might expand to form cumulonimbus, and that can bring rainfall along with thunder and lightning. So in the equatorial and coastal and the marine regions, in many of the cases, causes rains in equatorial areas on a daily basis. in the evenings. Or afternoons. Now, it will lead to simultaneous occurrence of thunder and lightning because you have formation of cumulonimbus sort of clouds. Then we have what is referred to as an orographic rainfall. We have seen that whenever you have a wind which basically ends up hitting a mountainous area or any region of a relief feature or any kind of obstruction, that wind is forced upwards. As that wind is forced upwards or rises upwards, it will experience a reduction in temperature because of adiabatic expansion, and that reduction in temperature overall will lead to condensation. So here you will have formation of very dense clouds. So that causes rainfall on the side of the mountain which faces the wind. Okay, ends up causing rainfall on the side of the mountain which faces the wind. So that is why this is also what is referred to as orographic rainfall, or rather the windward side. This is what is windward side. And this is what is referred to as the leeward side. Now, leeward side of the mountain will be drier because as the wind reaches here, by this time the wind has already become significantly dry. It has not got any amount of moisture left. And as it comes down, it further heats up. So as the wind heats up, what happens to the relative humidity in this case? As the wind heats up, will the relative humidity increase or decrease? Whenever you carry out the heating of air, the relative humidity tends to decrease. Very good. So relative humidity, when it decreases, saturation does not occur. That is why on the leeward side, because the saturation does not occur, this is a dry area. And that is referred to as a rain shadow region. Rain shadow region, which means in that area, you don't experience the occurrence of rainfall. Okay, these are dry areas. So taller the mountain, greater is the rain shadow region. So that is why on the leeward side of any of these mountains, you will observe there is no occurrence of rainfall or dry areas. Even on the eastern side of the Western Ghats, you will observe it is dry. Even in the northern face of Himalayas, you will observe that they are drier. So that is how you have the leeward side, which are dry and devoid of rainfall. Of rainfall. Okay. Now, then we have a frontal or a cyclonic rainfall. So this is created by or observed whenever you have a creation of a front or a frontal formation. That is something we will take a look into the next class. So when we say a frontal formation, that happens whenever you have a mass of cold and warm air, whenever they end up interacting with each other. So let's suppose you have warm air and you have cold air. So as the warm air interacts and the warm air here starts rising with the cold air, you will observe that as it rises up, let's suppose, in this region, in this area, warm air is in contact with the cold air region. So in that case, when the warm air is in contact with the cold air, the temperature of the warm air will also reduce. So that is when it will undergo saturation. If it cools down beyond that, you will have the formation of clouds in this area. And that is what ends up causing significant rainfall in the process. Okay, that will end up causing sufficient amount of rainfall in the process. Then we come across to the portion of fog formation. What do we understand by fog? So, fog is again a kind of a condensation, but here the condensation happens closer to the ground surface. So the definition of it for the fog is a cloud formation near the ground. But don't go by the definition, just understand in simple terms. Whenever condensation happens on the ground surface, near the ground surface, the air condenses near the ground surface. That is what we experience as fog. Now that condensation will happen because the air will lose temperature. Air can lose temperature because of different reasons. Because of different conditions, the air can lose temperature. But as the air loses temperature, that is why you have the formation of fog. Now, this condensation will happen on wherever you have the dust particles on the ground surface, across those areas. Now, near the ground surface, always there will be dust particles everywhere almost. So that is why you will have a lot of fog formation. Now, here we have the classification of fog based upon how that condensation has happened or why that condensation has happened. That is how you have the classification of fog into various types. So, fog is a cloud with its base at or very near to the ground, or a cloud that touches the ground. In simple terms, where the condensation has happened near the ground surface. Now, fog shows up when water vapor or water in its gaseous form condenses. There is another form of condensation which we refer to as mist. Now, mist is also very similar to the case of the fog formation. The only difference being that when we talk about mist, mist contains more moisture as compared to fog. Why? Because in each of the condensates that happen, the nuclei contains a thicker layer of moisture. That is the only difference. Otherwise, both are a type of condensation near the ground surface. Now, in this case, we have a classification based upon why is it that the air will lose temperature, why is it that condensation will happen. Based upon that, we have the classification. So here, the classification is on the basis of why the cloud formation, or rather why the condensation takes place. Okay, so we have radiation fog, we have advection fog, upslope fog, steam fog, and valley fog. All of these are basically condensation happening near the ground surface. But in all of them, the air is losing temperature because of different reasons. In the case of radiation fog, it is very similar to the case that we studied for surface inversion. And that is that the surface suddenly loses heat. And when the surface loses heat, surface becomes very cold. The air above it will also become very, very cold. And as the air suddenly loses temperature, it will attain saturation, it will cool down beyond it, it will undergo condensation. So here, which radiation are we referring to? Here we are referring to terrestrial radiation. It is because of terrestrial radiation. When the earth is able to lose heat very, very quickly. So radiation fog. This is observed when the surface loses heat very quickly, and as a result of that, just like the case of surface inversion, remember. So here, just like the case of the surface inversion, surface loses heat very quickly with the help of the outgoing terrestrial radiation. So as the surface loses heat, air above it also cools down very suddenly. Air cools down very suddenly. Cools down and undergoes condensation. Now, when this will happen, when is it that we will observe this? Whenever you have a condition so that the air is able to lose or the ground is able to lose heat very quickly. So what are the conditions under which the ground is able to lose heat very quickly? Let me know. Can we say long winter nights? Very good. Long winter nights. That is when the ground continues to lose heat for a longer duration. Other than that, clear sky, beautiful, right? Because in cloudy nights, you won't experience the fog formation because when you have clouds, they will re-radiate back some amount of that heat. It will cause warming. That is why lack of clouds is an essentiality for the loss of heat. So both of these further accelerate the rate of loss of heat. Also, if let's say you have wind movement, will you observe fog formation when you have wind movement? When you have wind movement, will you observe fog formation? No, because in that case, it will simply be blown away. It will simply be taken away. So here you also need calm conditions. That is lack of wind movement, right? Lack of wind movement. Now, next morning, what will happen? Next morning, as the sun starts to shine, it will heat up the ground. That will heat up the air above it. And that is how the fog starts dissipating. Because once the air gets heated up, again, its moisture carrying capacity will increase. It will be able to accommodate all that. So that is why radiation fog will dissipate from the region of ground surface upwards. So that is why you will have basically the fog dissipates in the morning from ground up. Okay, that is the aspect of radiation fog. Then we also have what is referred to as advection fog, which is created because of the process of advection. Whenever you have a process of advection, that is how it gets created. So for example, you have, as indicated by the image here, let's suppose you have a warm advection. You have wind moving over a colder area. So whenever you have a warm wind moving over a colder surface, the wind or the air gets in contact with the colder surface. So when it gets in contact, the air will also get cooled down. But this cooling down has happened because of advection. Had this advection not been happening, this cooling down would not have happened at all. So that is when, due to that, you have the cooling of the wind. Due to that, you have the formation of fog. As simple as that, generally observed in the case of warm advection. Okay, that is when it is generally observed. Now, then we have one of the most visually appealing kinds of fog, which is referred to as a steam fog. Now, when you talk about a steam fog, it is when you experience that the fog that you see in the image itself, it will appear as if there is steam rising from top of water. Okay, you will experience that kind of a movement as if steam is rising from top of water. But it is not steam which is rising, it is simply fog formation. So, how does this happen? When does this happen? So, this occurs when cold and dry air moves over warm water early in the morning. So, early in the morning, if let's suppose I consider a kind of a land area, and let's suppose I consider a water body. Now, the air above the ground, this will be cold air. right? Because early in the morning, the land will be colder, water will be comparatively warmer. Now, here, over the water body, you will have some or the other amount of evaporation, some rate of evaporation which will be happening, even though less, but there will be moisture which is going to be present around it. So there will be significant amount of moisture present over it, lot of moisture present over it. Now, as you will encounter this cold wind coming over, this cold wind will, in a way, lead to the condensation of all that moisture which is present. So this cold wind will lead to the condensation, right? Condensation of all the moisture. So all the moisture which is present, so this will lead to condensation of the moisture. So because this vapor always, as whenever you have evaporation which is happening, so in those cases it always gives you a kind of a visual appeal of as if it is rising. That is why when it condenses in that state, it will give you an appearance of such rising columns, which is referred to as the steam fog. Okay, so that is what you observe in the case of steam fog. So steam fog is experienced generally in the morning when you have some amount of evaporation which has already been initiated, or sometimes even late at night, you will experience this over the water bodies. It won't be experienced over the land areas. It will be experienced primarily over the lakes. Even in certain cases, if there is a river, in that case also, if the river movement is not very swift, there also you will experience the kind of a steam fog. Then you have what is referred to as an upslope fog. Upslope fog is the fog which is created whenever you have the rise of air or the slow movement of air over a mountainous or a hilly region. If the air moves very quickly or significantly faster, it will form orographic rainfall and orographic clouds. But whenever you have a kind of a very slow movement, so in that case of a slow movement, slowly and steadily the air will start losing temperature, and slowly and steadily it will observe a kind of a condensation and formation of a fog. So forms when wind blows air up a slope whenever you have an orographic uplift. And this is when you have slow movement of air, which happens in this particular case. Okay, that is your upslope. This is observed as an upslope fog. So whenever early in the morning, if ever you go for trekking or adventurous activities across the hills, you will observe that upslope fog. Then you have a valley fog, which is again created late at night or in the evenings. And the same process is followed that you observe in the case of the valley inversion as well. So here, what is that valley fog? So here, let's suppose you have a hilly or a mountainous area, let's suppose, and valley in between. So on top of the mountain, you will have cold air. Here you will have the presence of cold air. Cold air. Now that cold air, as it starts to sink, it will replace the warmer air at the valley bottom, isn't it? Now in the process, as the warmer air at the valley bottom, as it is pushed up, wherever it gets in touch or in contact with the colder air in general, that is where condensation will happen. So that is why the entire valley is almost covered with dense fog formation, where you won't be able to see any kind of thing at the bottom at all, right? So that is where you have the formation of a valley fog. As cold winds during the night, they come down in the valley, and there will be condensation of the entire warm air which is trapped in the valley. That will undergo condensation. That is what is referred to as a valley fog. Okay, so that is the case of the various different types of fogs which are created. Okay, so that is where we'll end the session here today. And we have discussed few of these questions. So tomorrow we will be starting with the portion of air masses and cyclones. Now I gather that you have your webinar right now, so you can leave. So take up the webinars, and all those who have not studied about the latent heat of condensation, kindly do that today. We meet again tomorrow. Uh, Garvit,